Okay guys, so the today lesson. The today lesson is the chapter 1 of the CCNP ENCOR, the packet forwarding. Okay. So when you get the brief idea, okay, brief idea of the packet forwarding. Okay. Let's how the packet form. Okay. So that means we have to talk about the three planes. Okay. I think already you heard about this. Okay. There is a three planes we have to talk about. Okay. There's a three planes. Okay. So the first plane is the control plane. Okay. The second one is the management plane. Okay. And the third one is the data plane. Okay. So when you get the a switch, okay, I'll draw it in here. When you get a switch box, okay, so inside this is the processing of the data plane. Inside this is the data plane. Okay. So think in here if you have a cable is interconnected, so think this is a fa 0 slash 1. Okay. So think this is a fa 0 slash 2. Okay. So now the the data plane is the forwarding table. Okay, it's forwarding the data traffic to another port. Okay, which we called as a forwarding table. Forwarding table. Okay. So now some of the packets can forward through the data plane, but some of the packet cannot. Why? Because the most of the IP packets can be forwarded by the data plane. Okay, but however, there are some special IP packets that can't be forwarded by the data plane immediately, and they are sent to the control plane. Okay, so top of the data plane there's a running the
So
control
excuse
plane.
me.
Yes.
So there are some peoples in the lobby.
Okay, wait. Okay, is there someone is going to log in? There's a one. Okay, one, two, three, four, 5, 6, 7. Only 7 students are logging, right? Is there anyone who is joined for the session? Okay, then let's move. Okay, so in the mainly in the switch box they have the data plane, right? In the data plane they are forwarding the data traffic. Okay, let's call as a forwarding table. Okay, so however there is some of the special IP packets that cannot forward through the switch box. Okay, I'll tell you what are the that special IP packets. Okay, so the first thing is the IP packets that are destined for one of the IP addresses of the multi-layer switch. Okay, so think this is a L2 switch. Okay, but in that case when you use the L3 switch, okay, think there's a one network is destined for one network. Okay, so think there's a VLAN 10. Okay, this is unique for 192.168.10.0. This is unique for this network. Okay, so some of the packets cannot forward like this. Okay, if we use in the routing, okay, we cannot forward the that data packets through the data plane. Okay, so that's why we are using the control plane, okay, to make the decision. So the second point is, okay, the first point is destined IP packets. Okay, I will mark it in here. Okay, the first point is IP packets, IP packets that are destined 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 for one IP address, for one IP address. Okay, and the second point is, okay, the second point is the routing protocol traffic. Okay, the second point is routing protocol traffic. Okay, for an example, OSPF packets, okay, EHGRB packets, EHGRB packets, also we can say the BGP. Okay, like these packets, the routing packets cannot forward through the data plane. Okay, and the third point is, IP packets that have some of the options set in the IP header. Okay, so the third point is the IP header. So IP header have a unique features. Okay, we'll talk about that later in the data packet. Okay, and the fourth one is the IP packets with an expired TTL. Okay, so you already know every packet have a TTL value. Okay, so think some of the packets are expired. Okay, so those packets are not forwarding through the data plane. Okay, expired TTL IP packets. Okay, IP packets. So these are the four criteria that why we are moving to the control plane. Okay, so in here we have a control plane. Okay, in here we have a control plane. So now the control plane make the decision. Okay, so think there is OSPF packets is processing. Okay, so in that case the OSPF packets are processing two things. Okay, the first one is the neighbor table, neighbor table, and the second one is the LSTB. LSTB means the link state database. Okay, we are deeply talking about these things, but in here this is just a explanation. Okay, in the routing part, in the advanced routing, we are talking about the OSPF already, also in the advanced OSPF also. Okay, so first just remember this name LSDB. Okay, and under this have the the unique table for the layer 3 that call the routing table. Okay, that call the routing table. Okay, so this is what happened if some packets are not forwarding through the data plane. So like these criterias, okay, so the packets are forwarding to the control plane. Okay, so in the control plane there is a unique interface that is forwarding those packets. Okay, think serial interface is 0/0/2. Okay, likewise there's a unique interface to forward the traffic. Okay, so this is what happened in here. Okay, so in this side is always the incoming IP packets. Okay, you have to write it down, it incoming IP packets. Okay, incoming IP packets, and this side is the outgoing packets. Okay, so this side is the outgoing IP packets. Okay, so all the special IP packets are forwarded to the control plane. Okay, it's in here. Okay, special IP packets, special IP packets. Okay, so what are the special IP packets? So these are the special IP packets. Okay, so these are the criteria that fulfill the special IP packets. Okay, so that for the packet forwarding. Okay, so also next I'm going to talk about the IP header format. Okay, also the next we are going to talk about the multi-layer switch. Okay, before we talk about the switches, okay, the catalyst switches. Okay, when we talk about the catalyst switches, okay, I'll write it down in here. The catalyst series switches, the catalyst switches, the catalyst switches have three family types. Okay, you need to know. Okay, the first family type is the iOS, is the first generation. Okay, and the second generation is a new. Okay, it's called iOS 6, iOS 6, and the third. Okay, third for the routers, which is called iOS XR. Okay, and for the data centers they are using a different type of switch family. Okay, which called the NXOS. Okay, the NXOS means the Nexus. Okay, so these are the catalyst switch types. Okay, so that's the forwarding plane. So I'm going to talk about the architecture levels. Okay, before that we have to talk about the IP header format. Okay, so for the IP header format I will write it down in here. Okay, IP header format, because some of these things will come for the exam to fulfill. Okay, so in the first, okay, we get the chart. Okay, in the first side, okay, let's start with the left side. In the left side corner have the version. Okay, in this bar it's called version. Okay, and next it's called the IHL. Okay, we are talking deeply these things, okay, in the next slides. Okay, but this is the format. Okay, you have to write it down. Okay, and next in this data packet, okay, so which type of service you are going to use. Okay, so it's in the service type. Okay, in here we are typing the service type. I think someone in the lobby. Okay, so this is called in the third is a service type. Okay, and next at last the total length of the packet. Okay, the total total length of the packet. Okay, this packet. And next under this we have a unique identification. We have a unique identification for this unique data packet. Okay, and next the fragments. Okay, in here they called the fragment. Okay, and under this, okay, we are dividing it to two parts. Okay, we are dividing it to two parts. The first part is the TTL value. Okay, so what is the TTL value? It's called, the TTL value is called time to live. Okay, time to live value, the TTL value. Okay, next is the protocol. Okay, and next we have a sorry, for the identification, the checksum values. Okay, for the checksum values. Okay, and next, same as the other packets, we have the two portions actually, the same. First one is the source address of the packet, source address of the packet, source address of the packet, and next the destination of the packet. Okay, where's the destination address? Okay, or port. Okay, and this thing called the 32 bits. Okay, which we have the as a IP header. Okay, so this is called the packet. Okay, inside the packet, like this it's showing. Okay, every detail we can capture in the Wireshark. We will see that what are the details. We can see the checksum values, we can see the TTL time, source address, destination address, service type, version. Okay, total length of the packet. Okay, all the things we can capture by the Wireshark. Okay, it's a advanced tool, so we have a separate session for the Wireshark end of the sessions. Okay, so we do that later. Okay, I'll explain everything in the data planes and other things. Okay, in the Wireshark. Okay, so this is the basic of the packet forwarding. Okay, so still we have to talk about the how the packet is flowing through the firewall. Okay, so let's talk about that in the firewall session. Okay, it's not included in here. Okay, so let's we talk about it in the firewall session. Okay, so next we are talking about the multi-layer switch. Okay, so in here I'll talk about the multi-layer switch. Okay, so in the multi-layer switch have a unique special feature. Okay, that called A6. Okay, what's the mean by A6? Okay, so the A6 means the special hardware that call A6 in the data plane. Okay, so now the A6 inside of the data plane. Okay, so you have to remember that A6 in the data plane. Why we are using A6? Okay, because the A6 mean application specific integrated circuit. Okay, this circuit is unique for what? Okay, that's what we need to know. Okay, the MAC addresses, routing tables, and access list are all stored in the ASIC. Okay, in the multi-layer switch have a unique circuit that's called ASIC. Okay, so that's include the MAC addresses, routing table, access list. Okay, so the ASICs includes three type of things. Okay, actually it's storing. Okay, it's stored three type of things. First, the MAC addresses. Okay, first MAC addresses, and second one is routing table. Okay, you know what is multi-layer switch? It can handle both switching and routing, but basically normally it work as switch. Okay, the routing table Okay, and the third one is the access list, ACL basically. Okay, so these are the three things that's storing in the ASIC. Okay, so the tables are stored in the content addressable memory. Okay, so that means the CAM table. Okay, so there are two parts you need to know. Okay, the first one is the CAM and the TCAM. Okay, the CAM table, okay, and the TCAM table. So in the exam also they are asking, okay, of difference between the CAM and TCAM. Okay, so first one by one I explain, okay, what is CAM table, okay, and what is TCAM table. Okay, so CAM means the content addressable memory. Okay, the content addressable memory. Okay, and the TCAM, I think again there someone is joining. Okay, okay, so CAM means the content addressable memory. I'll explain what is that. Okay, so the TCAM means the ternary content addressable memory. Okay, the ternary, okay, content, the same, the ternary content addressable memory. Okay, I know these names are, I think it's new. Okay, but you have to learn. Okay, so what is the difference between CAM and TCAM? Okay, so let's find out. The first one is the CAM table is used to store the layer 2 information. Okay, so mainly the CAM table, mainly mainly the CAM table is used to store the layer 2. Okay, layer 2 informations. Okay, mainly they are using for store the layer 2 informations. Okay, but the TCAM, why we are using TCAM? The thing is, the mainly TCAM table is used to store the higher layer information. Okay, it's storing, it's store, it's store higher layer informations. Informations. Okay, it's store the higher layer informations. Okay, is it clear? There's a two tables which we run, the A6, the CAM table and the TCAM table. The CAM table store the layer 2 informations and the TCAM table is store the higher layer informations. Okay, so I'll explain what are the layer 2 informations. Okay, so then you will get an understand about what are the things you are going to store. Okay, the first thing is you are going to store is the MAC address. Okay, MAC address details, it can be a source address or destination address. Okay, and the learning interfaces, and the next thing is the learning interfaces, whatever the interfaces which you are learning through the MAC addresses. Okay, all the things are stored in the CAM table. Okay, and next also the VLAN. Okay, to which VLAN the MAC address belongs. Okay, it's also included in the CAM table. Okay, so there are some MAC addresses MAC addresses, okay, that's that's belong to VLANs. Okay, so that's why we are using the CAM table to store the layer 2 information, MAC addresses informations, the learning interfaces, the MAC address that's belong to all the VLANs are stored in the CAM table. Okay, and next, the ternary content addressable memory. Why we are using TCAM? TCAM is using for store the higher layer of informations. Okay, like ACL rules. Okay, for the first one, and next one, the QoS information. Okay, the QoS informations. Okay, and the third one is the routing tables. The routing tables. Okay, so now all these things are stored in the TCAM, ternary content addressable memory. Okay, so this is which I'm going to give you why the A6 is needed. Okay, so A6 is in the data plane. Okay, so also in the router has a 4 built-in blocks. Okay, so is it clear in here? Is there anything you can ask me? Is there any doubts regarding this?
Until this point, it's clear, sir.
Okay, so you have to clearly need to know. Okay, in the exam also there's a drag and drop questions are coming, the difference of the cam and tcam. Okay, there will be a two of these things and there will be a two of these things, so you have to drag and drop for right cam table and the tcam table. Okay, for right answers you have to drag and drop. Okay, like these questions will come for the CCNP ENCOR exam. Okay, okay, next we'll talk about the router. Okay, so mm, okay, so I'm going to clear this whiteboard. Okay, next let's see how the router is forwarding the traffic. Okay, so let's see the router. Okay, so in the router mainly have a box called the switching fabric. Okay, okay, have a switching fabric. Okay, and the router also have a input ports and the output ports, right? So let's see, we have two input ports and two output ports. Okay, so this is called one input port, this is called another input port. Okay, and next let's see, this is another one and there's another one. Okay, so these two and these two. Okay, these two is the outgoing, these two is the outgoing ports. Okay, and these two is input ports. Okay, so within first router to second router. Okay, when we send the traffic, the switching fabric is going to decide the actions. Okay, that's called the routing processor. Okay, that called the routing processor. Okay, so within this routing processor it executes some commands. Okay, it's execute some commands. So let's see what are that those commands. Okay, so the first command is the execute routing protocols. Okay, it's execute the routing protocols. Okay, the routing the protocols. Okay, and next one is the maintains. Okay, it maintains the forwarding tables. Okay, the forwarding tables. Okay, these two it will go into check. Okay, within the switching fabric there is a routing processor. In this routing processor there is executing the routing all the processors, and the it's maintain the forwarding table. Okay, so have a input port, switching fabric, routing processor, and the output ports. Okay, so we are going to talk about that Cisco ASA firewall thing in the ASA firewall configuration side. Okay, so we have a unique lesson for the firewall. So when we have that lesson, okay, I'll explain how it's processing the data. Okay, how it's flowing the packet, okay, through the SA firewall. Okay, let's end up in here for this lesson. Okay, so next thing is the 3-tier architecture. Okay, I think you already know when come to the network design and planning. Okay, we have a different architecture levels. Okay, so it's include for the wired network, also in the wireless. Okay, so in the wired network we have a three different types, but mainly we are using two. Okay, the first one is the 3-tier architecture, and the second one is the 2-tier architecture. Okay, so now I'm going to talk about the these architecture levels. Okay, so the first one is the core layer. Okay, so when we see the 3-tier architecture, okay, the 3-tier architecture, so in this 3-tier architecture there's a three components which you need to know. Okay, so what are those things? The core, distribution, and access. Okay, the core, okay, and the distribution, distribution, and access layer. Okay, these are layers. Okay, so that means the access is a layer. Okay, so these two also layers. Okay, so each layer we are going to talk about how it's processing the data of the core layer, distribution layer, and the access layer. Okay, so the mainly the core layer is a high speed backbone that should be designed to switch packets. Okay, so this is called the backbone. Okay, this is called the backbone of the network. Okay, why this going to switch the packets, okay, as quickly as to optimize communication transport within the network. Also the optimization part also there. Okay, the network optimization is in the core layer. Okay, now you need to know. Okay, why? Because the core layer is the critical for connectivity. Okay, you know what is core layer. So the core layer devices are expected to provide the high level of availability and reliability. Okay, so the core layer expected two things. Okay, the first one is the availability, availability, and the second one is the reliability. Okay,
So excuse me.
yes,
So excuse me.
yes.
Can you explain regarding the ports, sir?
Ports. Which ports?
Those are those are logical ports, right?
No, no, these are physical ports. the input ports and outgoing ports. These are physical. It's physical ports which is connecting to the router. Okay, so inside the router is a routing processor. Okay, so in this routing processor is going to execute two commands. Okay, based on the routing protocol, it's execute the routing protocols, and also it's maintain the forwarding tables. Okay, so if you send one packet in here, okay, it will send, check the destination address. Okay, and also it's check the destination port address. Okay, and it will send, it's forwarding directly to that specific port, and it's forwarding to the destination after that. Okay, if there's another router, the same process is happening in the second router. So think there's a two different ISPs. Okay, it's also same happening in that those IPS routers. Okay, ISP routers. Clear? So this is what happened inside the router. Okay, clear?
Clear, sir?
Okay, so is there anything, if you have any doubts, okay, just directly ask me. Okay, it's better to understand these things. Okay. Okay, so let's move to the layers. Okay, so in the core layer have a two things. Okay, it's must the availability and the reliability. Okay, so a fault tolerant network design ensures that failures do not have a major impact on the network connectivity. Okay, the first thing is the fault tolerant. Okay, so what is the mean by fault tolerant? Mainly this is regarding for the high availability. Okay, high availability and redundancy. Okay, this is regarding the high availability and the redundancy. Okay, so the core layer should not perform any packet manipulation such as checking access list or filtering. Okay, so the core layer is not performing the access list, NAT, filtering, any of these things. Okay, which would slow down the switching of the packets. Okay, so the core layer, if it's processing some of these things, okay, it slow down the entire packet forwarding. Okay, so that's why we are not process those things within the core layer. Okay, the core devices must be able to implement scalable protocols and technologies. Okay, and provide alternative paths and load balancing. Okay, that's why the high availability and the redundancy is coming. Okay, for the alternative paths. Okay, also the load balancing. Okay, for an example for these things, load balancing, load balancing, load balancing, and next one is the alternative paths. Okay, so this is what is come for the distribution layer. Okay, so let's talk about the distribution layer. The distribution layer is located between the access layer and the core layer. Okay, so when we get the three boxes, okay, I'm not designing a network, but I
So
will,
excuse me,
yes,
uh, while you're explaining that high availability and redundancy, you inform that it will not process any filtering,
yes,
but does the core layer perform load balancing in any case?
uh, the case is it's not performing any other traffic types like NAT, ACL rules, okay, the
Okay.
filtering, but the load balancing is happening with this the multiple paths. Okay, so likewise it's not affect to the core layer performance, right? The
Okay,
alternative
so
paths,
load balance, okay. Alternative paths and load balancing will be performed by the core layer, right?
yeah, it's increase the performance of the core layer. Okay, it's not effect for the degrade or any. Okay, is it clear?
Yes, exactly.
Okay, So mainly you need to know there is no packet manipulation, okay, access list, any other filtering types, okay. So but there's a one thing, the load balancing is happening and the alternative path, okay, is coming in the alternative paths. Why? It's increase the performance of this core layer, okay. Okay, next the distribution layer.
So excuse me.
Yes.
How can we achieve high availability using this router, sir?
Within the high availability, so mainly HA is using in the firewalls, okay, but in the core layer we are placing firewalls also, right, in the 2-tier architecture. Mainly there's a 3-tier, okay. So 3-tier means the core, okay, and the distribution, okay, and the access, right. But in the 2-tier layer there's only 2 tiers, okay. The core and distribution is one and the access is there, okay. So now we are not performing a core router and any other devices directly, they are using a firewall, okay, because the ISP link directly come for the firewall, okay. And if there is another firewall, we can perform the HA, the high availability, okay. The switching is in here, the access layer is in there, okay. So like this design in there in the industry, okay, the high availability. But in the 3-tier also we can perform the high availability to enhance in the core layer performance, okay, with the redundancy, with the backup routers, okay. Is it clear?
Clear, sir? Can we use only two routers to achieve high availability?
It's based on the network, right? When we do the HSRP thing, okay, I'll show you. We are only in the HSRP, we are only using the active and passive, right? But there's another name, okay, there's another name I'm not mentioning in here, okay. You will confuse, okay. There's active is a main and there's a passive, there's a backup, okay, and also there's a third backup in here, okay. If these two things down, okay, there will be another backup, okay. I'll configure and show you in the HSRP module, okay. It's based on
Okay,
the
sir.
design, okay, it's based on the design, however, okay. Okay, let's talk about the distribution layer, okay. Just give me a second. Okay guys, can you hear me? Hello? Hello?
Yes, sir, we can hear.
Yeah, yeah, okay. Okay, next we are going to talk about the distribution layer, okay. So in the distribution layer, mainly is located between the access layer and the core layer. Why? Because it's only provide boundary definition by the implementing access list and other filters, okay. So now the distribution layer we are implementing access list, mainly ACL, okay. Also we are implementing filters, okay, mainly the rules. Also the distribution layer is define a policy for network and include high-end layer 3 switches, okay, and it's ensure that packets are properly routed between the subnets and VLANs, okay. So that's why the multi-layer switches are going to be the higher level. And also it's provide the policy based security in form of access control list and filtering. Okay, and also it's provide redundancy, load balancing, aggregation and summarization. Okay, for these things the aggregation and summarization I'm not mentioning here, but basically the redundancy and load balancing are there. Okay, so how the distribution layer is going to get this load redundancy and the load balancing same as this. Okay, it's using the protocols. Okay, mainly it's using protocols, and the redundant paths. Okay, this is how they achieve the load balancing and the redundancy. Okay, because it will properly routed all the networks, okay, within the subnets and the VLANs. Okay, so properly it will manage the network traffic basically on the distribution layer. Okay, so for an example, for the protocols like FHRP, okay, we are learning those things. Okay, for the redundancy paths also we are learning that. Okay, how we are going to configure our HSRP, okay, for the VLANs. Okay, not for the interfaces, for the VLANs. Okay, and next the access layer. Okay, in the access layer is the one of the closer to the users, the end devices. Okay, so this layer is going to find the users themselves. Okay, so it's only searching the communicate with the MAC addresses. Okay, and also includes the access switches which are connected to the end devices. And also it ensures that the packets are delivered to the end devices or endpoints properly. Okay, and for the main purpose of the access layer is going to be the physical connectivity between the user and the network. Okay, so the main purpose is, what is the purpose, what is the main purpose of this? Okay, to connect to connect to connect between users to the network. Okay, so this is the main purpose of the access layer. Okay, and also it's not just a cable. Okay, so because this between the end user and endpoint, the PCs and the access layer switches. Okay, also the security policies are, if we want, okay, we can enforce in order to allow the access to the network. Okay, so that means if we want, okay, if we want, we can create the security policies that who are going to access our network. Okay, for an example, okay, we can deploy the port security, we can deploy like port security. Okay, also network access control, NAC. Okay, so these things are why we are using these things, to enhance to enhance to enhance the to enhance the security policies, to enhance the security policies. Okay, that's why we are using these things. Okay, port security and NAC, but there's other security techniques which we are using in the L2. Okay, those things are also included in here. Okay, okay, so the access layer can provide the layer 2 switching, high availability, port security, also provide the QoS, ARP, VLANs. Okay, the virtual access control list, spanning tree, power over Ethernet and VoIP. Okay, so those are the unique features is included in the access layer. Okay, so port security and the NAC also there. Okay, the QoS, the quality of service, and the ARP, the address resolution protocol, and next the STP, the spanning tree mainly. Okay, and next the PoE, power on Ethernet, and also PoE plus. Okay, and next the last is VoIP. Okay, voice over IP. Okay, so these things are used for the access layer. Okay, okay, clear? Is there anything you need to know, or if there's any doubts you can ask me? Is it clear, or if you have any doubts you can ask me? Okay, okay, so I think it's clear, right? If the silent means hello.
Clear, sir.
Okay, so next we are going to directly to talk about the spanning tree. Okay, so to basics to advanced we are talking about the STP. Okay, not for the STP, we are talking about the PVST, PVST plus, RSTP and MST also. Okay, in the STP syllabus. Okay, so I'm going to this one. Okay, so our main topic is the spanning tree, right? Okay, the spanning tree, the spanning tree we called as the STP. Okay, so this is what you are going to learn. Okay, so mainly I'll explain why we are using the STP. Okay, so mainly the STP is going to enable the switches to become aware of other switches through the advertisement and the reception of bridge protocol data units. Okay, so mainly how the devices are going to communicate. Mainly for the Cisco devices, they are forwarding the CDP packets. Okay, mainly, but to identify a switch and the bridge identification they are using BPDU packets. Okay, there's a two packet types. Okay, CDP to send the informations, okay, of the devices, and it will connect with each other after that. Okay, but they are sending the BPDU packets, actually the advertisements, to identify the STP bridges. Okay, the informations. So also in the STP builds a layer 2 loop free topology in an environment by the temporary blocking traffic on redundant ports. Okay, so mainly why we are using spanning tree? To get a layer 2 loop free topology, right? So why we are using STP? To get a layer 2 loop free topology, right? Okay, mainly that's why we are using the STP. Okay, so if one interface is connect, the one link is connect, and there is a no loop, because there will be a one interface is going to forward the traffic and other one is getting the traffic. Okay, so that's mean someone is sending and someone is receiving, right? So there's a no loop, but for the redundancy purpose, okay, that's what come for the STP. For the redundancy purpose, when we link another cable, okay, then after that, okay, there will be a loop. Okay, why? The switch is going to broadcast the traffic to these switch ports. Okay, and this switch port is going to send that traffic to the same switch as a destination switch. Okay, when we get the packets from the sending device, okay, it will come in here. Also this switch ports is going to check and broadcast the packets. Okay, actually it's mirroring the packets to the same port. Okay, there will be a double packets. Okay, so mainly the STP operates by selecting a specific switch as the master switch and running a tree based algorithm, okay, to identify which redundant port should not forward the traffic. Okay, so mainly the STP process first one as the master. Okay, so how they get the election? First is send the BPDU packets. Okay, so there is a process. Okay, I'll explain that late. Okay, there's a process, and after that process, okay, so the first or second switch will come, one of the switch will come as a master. Okay, master switch as the main. Okay, other switch will come as the secondary. Okay, so STP has a multiple flavors. Okay, which I mentioned in the first. STP has a many categories. Okay, so the first basic category is the STP. Okay, the first category is the STP. Okay, which is well known as 802.1d. Okay, which is well known identification of the protocol 802.1d. This is the original specification for the STP. Okay, also there's another protocols which we have, the per VLAN spanning tree, which we called as PVST. Okay, so the PVST are Cisco proprietary protocols. So that means only the Cisco devices can use this protocol. That means only the Cisco switches can perform this protocol. Okay, same as the PVST plus. Okay, PVST plus also Cisco proprietary. Okay, and next we are going to learn about the RSTP. Okay, by default the Nimbus switches are come from the RSTP. Okay, not the STP. So when we have a RSTP, so it also have a recognition 802.1w. Okay, 802.1w. Okay, this is the well known recognition for the RSTP. Okay, but this RSTP protocol is a open standard protocol. That's why we are going to tell this protocol as IEEE. Okay, IEEE standard. IEEE standard protocol. Okay, also the STP is a open protocol. Okay, and next we are going to learn about the MST, a little bit advanced. Okay, but you have to learn the MST. MST also is a well recognized protocol as 802.1s. Okay, it's also well recognized as a IEEE standard. Okay, it's the same. So now we are going to talk every bit of detail in the STP and other stuff. Okay, so mainly the catalyst switches are now operate in the PVST plus RSTP MST modes, but in the all three of these modes are backward compatible with 802.1d. Okay, that means the next the next generation catalyst switches, the catalyst switches. Okay, the catalyst switches, are supports the PVST plus RSTP MST, but also it's backward compatible with the STP. Okay, that's what it means. Okay, so it support these things, but also it's backward compatible with the STP. Okay, and in the 802.1d STP protocol, every port transition through the following states. Okay, so now we are talking about the STP, right? So STP have a port status. Okay, you need to know the port status. Port status. Okay, so the when come to the port status, the first port state is the disable. Okay, the first one is the disable. Okay, why it's mean disable? Disable mean, you can think the disable means like a shutdown, right? Okay, so the port is in a administratively shut down position. So that mean disable mean it's mean the port. Okay, we can say the switch port, the switch port, the switch port is in administratively. Okay, administratively. Okay, administratively shut down position. Okay, shut down position. Okay, that's what we mean by disable. Okay, and the second one is the blocking state. Okay, the blocking state. So these are the states in STP. Okay, so why it's mean the blocking state? Because the switch port is enabled, that means the port of the switch, the port of the switch is enabled. Okay, it's not administratively done, the port is enabled. Okay, but the port is not forwarding any traffic. Okay, but the port, okay, the port is not forwarding any traffic in this time. Okay, in this time. Okay, so the blockade means the port of the switch is enabled by default, but the port is not forwarding any of the traffics, okay, at this time. Okay, that's what it mean by blocking state. Okay, because it's ensure that the loop is not created. Okay, the blocking state switch port is the one who is blocking the traffic. Okay, so the switch does not modify the MAC address table, and it can only receive the BPDUs from the other switches. Okay, after 20 seconds the switch port changes from the blocking state to the listening state. Okay, so every 20 seconds, okay, after that, okay, every 20 seconds it will change. Okay, the change the state is to blocking state to the listening. Okay, after 20 seconds. Okay, blocking state to listening. Okay, blocking state to listening state after 20 seconds. Okay, you have to remember these time values. Okay, because after receiving the BPDUs from the other switches, after 20 seconds the switch port changes from the blocking state to the listening state. So think this is the first switch, think this is the second switch. Okay, so now you are going to plugging, you get the cable and plug it to the second switch. Okay, now after 20 seconds after you plugging, okay, the switch port with listening, okay, is change blocking state to listening state after 20 seconds. Okay, that's what happened in the second cable. Okay, so next we'll come for the listening state. Okay, let's say next one is the listening. Next one is the listening. Okay, so in the listening state the switch port has transitioned from a blocking state and can now send or receive BPDUs. Okay, so the listening state switch port can send or receive okay, can send or receive the BPDU packets. Okay, receive the BPDU packets, okay, that's what happened in the listening states. Also it cannot forward any other network traffic. The duration of the state covers to the STP forward time. Okay, the next port state is learning. After 15 seconds the switch port moves from the listening state to the learning state. Okay, let's see the this time second, this 15 seconds. Okay, so when we come to the configuration, I'll show you the times. Okay, it's hold the 15 seconds, but also we can manipulate these times. Okay, so if we want to get a better time, so we can change that time. Okay, manually. Okay, so but the default time values are these things, the 20 seconds, 15 seconds. Okay, so do you know how the spanning tree? Okay, so when we talk about in here the spanning tree, okay, do you know how the election happens? Okay, with its share in the BPDU packets. After that, how the election happen? The election, how it's happening? The election. Okay, To happen in the election, okay, the switch must need to identify the bridge ID. Okay, the switch must identify the bridge ID. Okay, I'll write it down in here, the bridge ID. Okay, to identify the bridge ID, okay, you need two parts. Okay, the first one is the priority. Okay, the priority value of the switch, the priority. Within the priority, it's include the base priority, it includes the base priority. Okay, base priority also it includes a unique sentence, the system extension ID. Okay, I'll explain what is this. Okay, and also it's need a unique address which called the MAC address. Okay, so these two is must to identify the bridge ID. Okay, this is the equation. Okay, if you think so, to happen in the election, it's finding the priority values and the MAC address. Okay, so there are two basic ways to manipulate the configuration to control the location of the route. So mainly this is the next step. Okay, but the first thing is I'll show you what happening within the STP. Okay, the basic things. Okay, in the very first time I'll get the two switches. Okay, so yeah, so I'll start the two switches and opening the console. Okay, let's move that in here, and the first switch you see in here. Okay, so let's see, so IP interface brief. Okay, so these are the interfaces which we have in the this switch. Okay, so all are ethernet switch, ethernet ports. Okay, so that means this switch is perform only the 10 megabit per second ports. Okay, ethernet ports. So let's see the spanning tree. Okay, show spanning tree. Okay, now you can see the spanning tree, right? Okay, so in this spanning tree is enable protocol is RSTP. By default this switch enable the RSTP protocol, but same as backward compatible with the STP. Okay, so and I'll explain one by one the root ID. Okay, the root ID means the root bridge of the switch. Okay, so that means if there is two switches, okay, the once the election happen, after sending the BPDU packets they gathering the informations. Okay, after that, after the election happen, okay, so they select one switch as the main one. Okay, it's like the main election. Okay, so when I check the IOU2, okay, let's see the show spanning tree. Okay, same as, okay, now the this bridge is the root. Also in this bridge is the root because there's no physical linkage interconnect with these switches. Okay, So that's why they identify as they are the root bridges. Okay, the root bridge means the main bridge, that means main switch. Okay, that means every traffic is forwarding through the core layer is going to be the root. Okay, so I'll explain that. So the first thing is you have a root ID. Okay, you have a priority. Okay, so priority the based on the switch. Okay, so mainly I write it down in here. Okay, mainly the priority. Okay, when we set the priority value. Okay, when we set the priority value, when we set the priority value, okay, it's need two things. Okay, the first one is the default priority, that means the base. Okay, that means the base plus system existent id. Okay, so that means the base value is 32,768. Okay, but also it's include the VLAN ID. Okay, just remember it is VLAN ID. Okay, now it's processing the default VLAN one, right? So that's why 32,768 plus 1, that's why it's showing that 32,769. Okay, it's showing 32,769. Okay, it's always same. Okay, because by default it's showing like this. If we change the VLAN, okay, think if we change it to 10, okay, it will add the 10 values. Okay, for the base value. Okay, then it will be 30,700 another value. Okay, it's a different value. So now you can see the MAC address, right? So MAC address, when we check the, I'll get the different color. Okay, the last digits, okay, 0100. Okay, and the second switch also have a last digits. Okay, 0200. Now this one have a 0100. Okay, this one have a 0200. Okay, so which switch has the lowest MAC? Is this one, right? Okay, by default it will be a root bridge. Okay, because when we check the bridge ID, okay, when we check the bridge ID, okay, is equal to priority plus MAC, right? Okay, first we are going to check the priority value. Okay, this is the first priority, so this is the second priority. Okay, first we are going to find the first priority value, so it's the 2769, also in same as the second switch. Now next we are going to find the second value, the MAC. The MAC is always unique for that device, right? So we can see 0100 in here, 0200 in here. Okay, these are different values, so the lowest value has the main priority. Okay, so there are two IDs, right? Root ID and the bridge ID. Okay, so root ID means carry the informations the informations the informations about the information about the root bridge. Okay, the main device. Okay, the bridge ID is gathering the information of the current device. Okay, the current device information, current device info. Okay, that's what it means, the bridge ID and the root ID. Okay, so next I'm going to plug these switches. Okay, then you will see. Okay, so next we have to check the forward delay. Now this is a unique. Okay, when we talk about the listing, okay, it's called the 15-second, right? Or let's have a 15-second. Why? Because when the duration of the state covers the STP forwarding time, okay, and the next port state is learning, okay, after the blocking. Okay, so that state have a learning value after 15 seconds is learning. Okay, that's why the forward delay time is 15 seconds. Okay, hello time is 2 seconds. The max age time they are given the 20 seconds. Okay, so the switch port moves from the listening state to the learning state. Okay, that means it's forwarding. Okay, listening state. Okay, I'll write it down here. The listening state. Okay, listening state to the learning state. Okay, it will learn in the switch port learning state. Okay, that's what it mean by this 15 seconds. Okay, so now you have a basic idea of the STP, right? Okay, now next I'm going to plug the cables. Okay, so first I have to shut it down unless the cables are not. Okay, now it's in calendar, right? Okay, now let's see the show spanning tree. Okay, let's see what happened. Okay, so now the previous time when we check the IOU1 and IOU2, the first switch and second switch, okay, both are root bridges, right? Both are root bridges. Now let's see what happened for this. Okay, so one of the port, okay, which is learning by the interfaces. Okay, let's see, Ethernet 000 and it's also in Ethernet 00. Okay, so let's see in the IOU1 and IOU2. Okay, so now you can see, okay, in here, okay, the root ID of the MAC address, the informations, and also the bridge ID of the MAC informations are both same, both are equal. Why? Because my IOU1 is the root bridge. Why? What is the reason? Because when we check the priority value first, okay, both devices have the same priority value, but when we check the MAC address, the MAC address is unique for that device, which is given by the manufacturer. Okay, so when we get the reason, okay, we have the lowest address. Okay, that means the 0100. In here it have the 0200. Okay, now who is the lowest? Is this, which is the lowest MAC address. Okay, so it will send the BPD packets. Okay, it send the BPD packets. After that, okay, it will get the updates from here. Okay, and it will learn. Now this which is sending a message, I have the lowest MAC address, then I'm going to be the root bridge. Okay, so also you can see every root bridge is connecting for one of the non-root bridges, non-root bridge. Okay, so there's a theoretical part. Okay, every non-root bridge have the root forward ports. Okay, that means whatever the traffic, okay, which is coming from this side, okay, from the under below, okay, all the traffic will forward through this interface, okay, to the root bridge. Okay, but the root bridge is not sending any other traffic types for the non-root bridge, because this is the main switch and it forward the all the traffic to the core layer. Okay, so top of this, okay, have the core layer. Okay, and every traffic which is come from this side and this side is going to be processed in here and forwarded to the core layer. Okay, that's what happened. So also you can see the root ID of the bridge ID is, you can see, so we can trace down the MAC address and find the right switch of the root bridge. Okay, and next the bridge ID also same as this is the information of the current switch device. Okay, so this is the current switch device, so it's hold the IOU2 name, so it's have the this unique address. Okay, so think there's a design failure. Okay, now now this switch is the root bridge, right? So I want to make this IOU2 as my root bridge, my main bridge. Okay, because we are changing the ISP. Okay, now I am going to send the old traffic, because in the previous the old traffic is come from this side, but in here I am going to connect it to the core layer in here. Okay, now I want to send the old traffic from the IOU1, okay, for the IOU2, and the IOU2 is going to process the every traffic for the core layer. Okay, so how we are going to configure that, how it's happening? Okay, so first thing is we have to manually manipulate. Okay, that means we have to manually configure these things. Okay, because there are two basic ways to manipulate the configurations to control the location of the root bridge. Okay, we can control the location of the root bridge in any device. Okay, think these are multi-layer switches, no? Okay, these are MLS, but think there's an access switches newly we are adding to the network. Okay, so this one have the lowest, this one have the lowest thing for imaging. Okay, this one have the lowest MAC address. What happened when we connect this switch into these two MLAs? This will become the root bridge. Okay, and then the entire network which is connecting to these switches, okay, will forward all the traffic to this switch. Okay, once this switch will make the root bridge, after that the all the traffic will forward to the this access layer switches. What happened, the entire network will be collapsed. Okay, there will be a huge traffic. So to make sure that these interfaces are heavily guarded, okay, there's a security mechanism which we learn from next sites. Okay, to overcome like these situations. Okay, so all the things are we are learning after we learn these techniques. Okay, so I'll show you how to overcome these issues. Okay, okay, next thing is I'm going to manipulate it. Okay, so there's a mainly we can change the value, okay, of the VLAN ID. Okay, the priority value we can change, but mainly in the industry we are using a simple command to make the primary and secondary command. Okay, so we'll do that in here. Okay, I'll show you actually how it's working. When you capture in the interface, okay, you will see every time it's sending STP packet. Okay, there's a no traffic. Okay, now it's sending traffic, a CDP, because who is the one who is making the first traffic is the 002, right, the second switch. We can trace the MAC address, right, and the first MAC address is still not sending a data. Okay, oh, let's see, yes, now it's sending the data. Okay, now we can trace the first switch MAC address 0100. Now it's sending a reply. Okay, and also it's performing the dynamic trunking protocol, DTP. So let's we will discuss later this protocol, dynamic trunking protocol, because it's only for the Cisco devices, which is when we connecting each other, with the different switches, so it will automatically trunk. Okay, that's why we are manually uh, shut down the dynamic trunking protocol, okay, for a specific thing. Okay, so let's see. Okay, so now I'm going to configure these switches. Okay, so first switches, you know, this IO1 is now your device, right? The main root bridge. Okay, so I'm going to make it happen. Okay, so first I'm going to configure the IO2. Okay, so the first command is, first you have to configure the spanning tree. Okay, so next you have to mention the VLAN, and next you have to mention the VLAN ID. Okay, so the first VLAN is VLAN 1 because now we are in VLAN 1, and next I'm going to make the root. Okay, the primary and secondary. The primary means the configure the switch as the primary root for this spanning tree. Okay, the spanning tree is hold the VLAN 1. Okay, so I'm going to make this as primary. Okay, next I'm going to make this switch as secondary. Okay, if not, let's see what happened. Okay, let's see. Okay, it's better to check everything. Okay, so let's see. When I check the spanning tree, now you know, manually, okay, manually it's degrades its priority value. Okay, to 24,577. Okay, because it's the values of the 4096. Okay, so multiplication of the 4096. Okay, so I'll show the base practice also. Okay, so in here 24,577. Okay, now this is our lowest priority value, but the MAC address is not changing because the MAC address we cannot change. Okay, 0200 is still same, but we can change the priority value. Okay, when we configure the switch, this switch as the main root bridge, the making as this primary. Okay, it will automatically change the priority value 24,577. Okay, but let's see what happened to this switch. Okay, okay, so let's see. Okay, so what happened? This will automatically change, right? Why? Because now it's showing my root ID is this MAC address switch, right? It's mean the second switch address, so it will automatically change because the priority value is automatically change when we make this switch as the primary. Still, if this is the core layer backup, okay, so we have to make this as the secondary. Okay, why I'm asking that? Because now the priority value is 24,577, right? So now think, in your company there's another switch is newly come to configure your network. Okay, and this switch, okay, let's start this switch and let's get the console. Okay, I'll show you why we need to configure the core layer and the backup core layer as the make as the primary and secondary. Okay, it's a multiplication of 4096. So let's see, uh, let's see. Okay, so I'm going to make spanning tree. Okay, VLAN 1, I'm just configuring. Okay, spanning tree VLAN 1. Okay, so I'm going to change the priority, so I'm using the priority command now. Okay, so priority I'm going to change it is it's 0 to 1440, so it's the increment of 4096. So if I check again, it's still have. Okay, so let's see the increments of 4096. So I'll check 4096 into 4096 into 2. Okay, it's 8192. Okay, let's see into 3. Okay, it's 12288. Okay, let's see in 4, it's 6384. Okay, so let's use that value. Okay, 6384. Okay, now this access layer switch has a lowest priority value. Okay, maybe it can be happen in the production network. Okay, so once when I connecting these three switches, okay, so think this is access layer switches, so I'm going to connect it with this the main core layer and for the backup layer also. Okay, so let's see, I don't think so it's connecting now. Okay, so I'm connecting that 01201. Okay, okay, now IOU3 is connecting. Now it's sending the BPD packets around the switches. Okay, the election is re-happening. Okay, but still you can see what happened for this. Okay, now you know the IOU2 has the priority, so this will make us the primary, right? So we'll see these type of things will happen, the scenarios. Okay, so I'll show you that. Okay, let's see in the IOU2 and the IOU3. Okay, IOU2 in here, IOU3 in here. Okay, so let's make sure that I have configured. Let's see in the spanning tree what happened. Okay, now this IOU2 is not the main root bridge, right? Why? Because I changed the priority value. Okay, because the priority value I changed this to 6384. Okay, but it's at a VLAN value also. Now it's holding the value as 6385. Okay, let's see what happened to this. Okay, okay, so let's see the shows spanning tree. Now what happened, the entire topology is changed now. Okay, now the traffic will flow entirely different. Okay, whatever we are designing or configure in previously, now it's entirely changed. Why? Because the access layer switch has the lowest priority value switch. Okay, that's the one main configuration fault. Okay, so now before we configure or before we attach the switch into a network, okay, we have to check everything. Okay, the details. So the first thing is this is become the root now. Okay, because this is our lowest priority. Okay, not the MAC address. Okay, because when I, okay, when I say that the bridge ID, okay, the bridge ID is equal to priority plus MAC address. Okay, so this is the equation you have to remember. For first priority will come for the priority value. Okay, this is the first and this is the second. Okay, so it's how the MAC address is not the lowest value. Okay, it's mean the 0300. Okay, it's not the lowest, but it has the lowest priority. Now it will become the root bridge, because when we see the equation, okay, you will see the first priority we are giving for the first. Okay, so that's the reason. Okay, so to overcome these issues, okay, I'll give you a solution. Okay, I'll give a solution for this. Okay, so first thing, now this is your primary, right? Okay, now when you see, okay, think this is your main. Okay, this is your backup. Okay, so let's see, this is my main, so this is my main, this is my core. Okay, so this is my backup. Okay, so this is my access layer switch, this is L2. Okay, now all the traffic which is coming from the L2, okay, it's forwarding to the main switch. Okay, if the main switch is failing, okay, all the traffic will automatically is sending for the backup, and it will send for the second ISP. Okay, it will send the second ISP, this is the first ISP. Okay, so now it is send, if it fail somehow in the main switch, it will send the all traffic to the second ISP. Okay, through the second backup. Okay, the backup switch. Okay, the backup core. So to configure this topology, okay, already it's the access layer is become the root now. Okay, so what can we do? We can mainly we can set the priority value as primary and secondary, but it will not affect. Okay, when we have a, again when we have a, so think somehow, okay, think somehow the attacker has the lowest priority value, think it's like a 4096. Okay, so when he connects that switch into our network, okay, the entire traffic flow will be flowing through this switch, right? It will happening. Okay, even when we configure this as the root bridge, and this as an this is the second root bridge. Okay, as like this, even we configure like the primary and secondary, okay, it's not effect, because still I'm configure this switch as the primary, but when we connect my access switch, okay, the primary will go. Okay, so to overcome like these issues, okay, there's an one solution. Okay, there's a other solution, but mainly we are using this solution. Okay, for the IOU1. Okay, for the IOU1, so I'm making this. Okay, spanning tree. Okay, the VLAN 1. Okay, and let's say the priority value I'm going to set as 0. Okay, why? Because it's the lowest priority. Okay, now there's a no priority value lower than 0. So let's make this clear. I'm going to check this. Okay, now I'm going to check this 0. Okay, again 0 to 4096. So next priority value is the 4096. So I'm going to configure the IOU2 as the second one. Okay, the secondary backup. So I'm going to configure that. So first the spanning tree. Okay, spanning tree, sorry, the VLAN 1. Okay, the priority value is 4096. Okay, spanning tree VLAN 1 priority 4096. Okay, now let's see what happened to the network. Okay, so IOU1, let's see the spanning tree. Okay, now the spanning tree, the priority value is 1. Why? We know the answer. Okay, what is the answer? Because it's asking the base priority, okay, plus the VLAN ID, right? So the base ID is 0. I'm going to change that. The VLAN ID is 1. 0 plus 1 is 1. So that's why it's showing 1. Okay, so is it clear, everyone? Is it clear?
So excuse me,
Yes.
when we are connecting the switches
Okay.
with ISP, what is the correct setup should we connect?
uh okay, so I'll explain with the design. Okay, in next slide. Okay, because it's a different part. you're asking me that how we are going to configure all the switches, okay, with your core layer router, okay, then how the design is working, right? That's your question.
Yes, sir.
Okay, so I'll
Yes, sir.
explain in next
What is
slide.
the
Okay.
what is the root bridge and other
Yeah,
switches?
so I will explain that later, okay, because it's a another part. Okay, I'll explain definitely, okay, after this session. Okay.
Okay, sir.
Okay, so now you know the priority value is 1. Okay, now let's see in here. Okay, okay, now you know this is the secondary priority value has, this is the switch. Okay, now this is a 4097. Okay, so now this is the secondary value. Okay, still we have access switch, right? So let's see what happened to the access. Now it's showing, okay, the root id is the 0100. Okay, now the all the traffics. Okay, so I'll show you that. Okay, you're asking the design. Okay, so I'm showing you that now. Okay, so now I'm explaining this port. Okay, in next slides. Okay, so I'm explaining one by one each other. So what is route forward, what is alternate block, what is designated forward, I'll explaining one by one. But in here I'll show you the, when you're asking me the design. Okay, so ethernet 00 is the route forward, right? Okay, so now every traffic which is coming from the LAN side, okay, which is come from the LAN side, okay, it's forwarding not in this side. Okay, because you can see ethernet 0/1 is the alternate block. Okay, this is a block port. Okay, it's not sending any traffic, because this is the only port which is sending the traffic to our core switch. Okay, this is my core. Okay, this is my backup, this is my backup. Okay, this is my core. Okay, so in that case the only traffic will be forwarded through this route forwarded interface. The route forwarded interface is the ethernet 00, this interface. Okay, this interface is the only interface which is forwarding traffic. Okay, okay, now let's see other interfaces. Okay, let's mark it down. Okay, SCC. Okay, so this interface is a route forward. Okay, this interface is alternate block. Okay, so now let's see the other interface also. Okay, now we have a ethernet 00. Okay, ethernet 00 means is a route forward. This interface is a route forward interface. Okay, and the 01 interface is a designated forward. Okay, so I'll explain what is this interfaces. Okay, I'll explain one by one. So designated interfaces, the interfaces which is getting the traffic. Okay, it's not forwarding, it's receiving. Okay, the route forward interface always forwarding the traffic. Okay, but it's not generating the traffic in here backup. Okay, because the backup switch link is down. Okay, now the only interface is going to be sending is the ethernet 00. Okay, now let's see the core layer switch. Okay, in the core layer switch only have a designated forward. Why? Because the core layer switch is not forwarding any traffic. Okay, because it's only receiving interfaces, it's only have receiving interfaces. Okay, so that's why all the interfaces are in the core layer switch is designated. Okay, it's only receiving, but when we connect this interface into a router, okay, it is a route forward. Okay, it is a route forward when we configuring. Okay, when you connecting this switch into a router, okay, this link will be route forward, it will automatically. Okay, and it forwarding the all the traffic to the ISP. Okay, so design wise this is the pathway, this is how the packet is flowing through the network. Okay, is it clear? Is there any doubts? I'm explaining all the things. Okay, the alternate block, what is the designated forward, we have the session. Okay, is there any doubt regarding this? Anyone?
So core switches cannot forward traffic, no?
Yeah, yeah. The core switches cannot forward traffic, but when we connecting it to the ISP router, okay, or any router, the link will be route forward. Then it will forward the traffic, but not in the switching environment.
So how can complete the communication process within the switches?
Within the switches, the pathway it will automatically decide, because when we manipulate the priority value and the other mac things, okay, when we change that, okay, this is automatically forwarding the traffic, okay, because the only traffic which is forwarding is route forward port, okay. The access layer switch has only one, okay, that's mean the only ethernet 00 can send the traffic to the core, okay, but not in this side. This side is blocked, because this side is alternately blocked, okay. So it always show, okay, when you see the IOU3, okay, you can see this interface is alternate blocked, okay, it's not performing any traffic, it's not forwarding or receiving any traffic. That's the reason. So this is how you are going to manipulate the STP, okay, this is called STP manipulation.
So when we are connecting two switches,
Okay.
uh, I think both need TX and RX.
Yeah, so now when you see the TX, okay, so TX means transmitting, RX means the receiving, right? So this interface is the TX, so this interface is the RX, okay. So this interface is blocked, okay. Now this interface is again transmission, okay. But the thing is, there's no traffic to transmit, because this entire link is blocked, okay. So all the traffic is forwarding through the in this side, this way, okay.
Clear, sir. Clear, sir.
Okay, understood. So when you're configuring a switch, okay, think there's a 10 or 15 switches, so you have to manipulate it by manually, okay. The way you are configuring the STP, it will send all the traffic like this. It's like a flowing water flow, okay. It's like a waterfall, okay. So you have to manipulate manually, then the traffic will be automatically flow that pathway. Clear?
Clear, sir.
Okay. Okay, so this is a one point, okay. So let's see. So attacker, think there's an attacker, okay. The attackers are not like a dummy people, they are very intelligent. So think that attacker have a switch that have a lowest priority as 0. Now let's see what happened that, okay. So think there's a attacker, so have the switch has the lowest priority value as 0, okay. Let's see what happened for this like these scenarios, okay. Let's see. Okay, let's see. mm, so I'm going to get again another switch, okay. So I'm going to rename this switch as attack, okay. Now this attack switch is not connecting to the core layer switches, okay. It's only connecting to the access layer switch, okay, because the core layer switches are in the server room, okay. You know that, right? So normal persons cannot access the server room, but the access switch can access, because it can be anywhere, okay, in the building. So someone can access, okay, anyway. So the attacker, so I'm going to start this switch and do the configuration. Okay, So let's see, spanning tree, VLAN 1. Okay, the priority value I'm setting as 0. Okay, now let's see, do show span. Okay, you don't need to go back for the what it called the privilege level. Okay, you can do the configuration in here. The show commands, it's work with the do. Okay, do show span. Okay, so you can use the simple command also. So now this bridge is the root. Now the priority value is 1. Okay, now the attack switch has the lowest priority. Now I am going to connect it to my access switch. Okay, let's see what happened after that. I'm going to use the Ethernet 2/0, again 2/0. Okay, now again the entire process, the entire election will be happen, because the core switch also sending BPD packet, the backup switch also sending BPD packet, because the now the block alternate block is different. Okay, now again the access switch is sending to the core layer for the BPD packet, and also the attack switch is sending BPD packet to this one. Okay, so the again reelection will happen, but we can see, okay, that will happen. So when we start the capture, okay, okay, so again it will send, the first is still performing the STP packets. Okay, one by one it will selecting the route. Okay, you can see the details. Okay, it's see the route. Okay, and it will trunk, and then again send it the series. Now you can see 0302 0402. Okay, the device is called the attack. You can see the name, right? The device ID is attack. Okay, so now you can see it's sending the packets, okay, for the network. Okay, now it's ending. Okay, now I'm going to close this one. Okay, I'm going to stop the capture. Okay, now let's see what happened for the attack switch. Okay, I think I have that. Okay, now we can see what happened. Again, when the attack has the lowest priority, you can see the root ID. What happened? It's not changed, right? Because when we configure, this is the MAC address of our core layer switch. Okay, so this is the MAC address of our attacker switch. Okay, also when the attacker comes from the lowest priority, it's not changed. Okay, because the firstly we are configured the this core layer as the main. Okay, also the, do you know what is the actual reason for this? The actual reason is, okay, the actual reason is the priority values. Okay, so we have a IOU1, IOU1. Okay, we have a attacker switch. Okay, attacker switch, so both have a same priority. You can see the priority values are same, but when you can see the MAC, okay, 0100, in here the MAC address is 0400, right? You can see. So first the election happens. Okay, after that, now they know, okay, the priority value is same. Okay, the priority value is same, but again we have to check the MAC address, because the protocol says the bridge ID, okay, the bridge ID, the bridge ID is equal priority plus MAC. Okay, so first we are identifying the MAC priority, and second we are identifying the MAC. Okay, if the priority values are same, equal, okay, if the priority values are equal, we are going to check the second parameter. The second parameter is the MAC address. The MAC address are different, so who has the lowest MAC address, it will become the root bridge. Now the our core layer has the lowest MAC. Now the core layer still become the root bridge. The election is win. Okay, this is what happened in the production networks. Okay, so I think all are clear in here. Is it clear? Okay, can you move to the next one, because the next one is the theoretical part. Okay, we have to talk about the RSTP protocol also. Okay, we have to check the differentiate. Okay, okay, did you get the STP? I think the STP now you know how to manipulate, right? Is it clear?
Clear, sir.
Okay, I think all are done, right? Others? Because we are not, again we are not talking about the STP because we are moving forward. Okay, so next I'm going to talk about the RSTP. Okay, after that I'm going to talk about the MST. Okay, MST is a big concept. Okay, okay, I think all are clear now. Okay, I think the practical session is also clear, right? Okay, let's close this one. Let's minimize that and we'll again come to the whiteboard. So we have to next we are going to talk about the STP. Okay, but there are some things you need to know. Okay, the first thing is the difference between the two of the priority command will set the specific number. Okay, the multiplication of the 4096, you know. Okay, the first thing is in the STP manipulation. Okay, we get the STP manipulation. STP manipulation. Okay, the very first thing is you can change the priority. Okay, the priority command will set the specific number of multiple of 4096. The first thing is the multiple of multiplication of 4096. Okay, so the second one is it will make as a primary. Okay, or it can be a secondary. Okay, these are the two things you can change the location of the root bridge, location of the root bridge. Okay, this will to help. Okay, so next, if the local bridge mac is lower than the current root bridge mac. Okay, so think of the 4096 lower than the current root's priority value. Okay, so if the local bridge mac is higher than the current root bridge mac. Okay, so that's based on the theoretical part what we configured. Okay, so the logic behind this operation is straightforward. Okay, you know that. Okay, the root primary commands tries to lower the priority only as much as is needed to win the root election. Okay, so when we configure the primary, so it will decrease the value again. Okay, if we want, okay, again it will decrease. Okay, to win the root election while leaving the priorities between 24,000 24,576. This is the first value, it will decrease. Okay, you have to remember this. Okay, so this is the things what I need to tell you. Okay, so next we are going to forward into the RSTP. Okay, next we are going to talk about the RSTP. Okay, RSTP, the rapid spanning tree protocol, the rapid spanning tree protocol. Okay, okay, So first I want to tell you it has a inbuilt features of Cisco proprietary protocol like port fast, uplink fast and backbone fast. Okay, mainly the port fast. Okay, the port fast feature I'll tell what is that port fast feature. Okay, so RSTP port have a status. Okay, same as STP, it have a unique status. Okay, so first thing we are going to talk about is the very first thing we are going to talk about is the RSTP port status. Okay, port status. Okay, so I have to tell you the standard 802.1w. Okay, so now we are going to talk about the RSTP port state. Okay, so the first status is discarding. Okay, so I'll write it down in here. Okay, okay, the black pen. The first one is discarding. Discarding, I'll compare this with the STP. Okay, these things, discarding and learning and forwarding. Okay, and learning and the third one is the forwarding. Okay, so these are the three port status in RSTP. Okay, so first I'll explain what is discarding. Okay, so discarding is the when the switch port is enabled, that means switch port is enabled but the port is not forwarding any traffic, like same as administrative shutdown. Okay, so any traffic, to ensure that the loop is not created and the status combines the traditional STP status disable, blocking and listening. Okay, so discarding, okay, discarding will come from the STP. Okay, disable, blocking, listening status. Okay, it will hold the status when we check these are the RSTP port status. When we check the STP, okay, it will hold. Okay, disabled, disabled and blocking. Oh, wait, blocking and listening. Okay, so discarding of the RSTP hold the STP disabled, blocking and listening status. Okay, and the learning is come from the learning. Okay, learning is not different, it's learning, it's learning. Okay, but the forwarding is also forwarding. Okay, it's also the forwarding status. Okay, so when we have the STP, to run the STP service, okay, to run the STP service properly, it will get 50 seconds. Okay, it will get 50 seconds. Okay, but to run a RSTP service it will only get 1 second. Now you can imagine who is the better fast protocol. Now you can see who is the best. Okay, that's why every industry we are using the first RSTP, the first protocol as RSTP. For the design purpose we can change to PUSG, PUSG plus and the MST, but the first protocol is RSTP. That's why when I enable a switch in my GNS3, that switch is configured by default in RSTP. Okay, that's the reason the newest devices are all are configured with the RSTP. Okay, so what is the mean by discarding? Okay, is the same as the disable, okay, of the STP. It's not forwarding any traffic to ensure that the loop is not created. Okay, is discarding state is disabling the loop. Okay, and the learning state same as the STP. The switch port modifies the MAC address table with any network traffic it receives. The switch still does not forward any other network. Okay, it's only learning the MAC addresses which is connecting to the network, okay, but it's not forwarding the traffic, okay. Only the forwarding state is forwarding the traffic, okay. That's mean the switchboard forwards all the traffic and updates the MAC address table as expected, okay. So only the forwarding state it will forward the network traffic, okay. Until then it will hold, okay. And next which I give you the next the RSTP port roles, okay. The first one is RSTP port status. I think you clear this one, okay. If not you can ask me, okay. The next thing is we are going to talk about the second point, okay. In the RSTP, the RSTP port roles, RSTP port roles, okay. So in the RSTP port roles, okay, also we are going to talk about the 4 port types, okay. So let's get the first pen, okay. Let's see the first one, okay. The very first one is the root port, the root port. I'll explain what is root port, okay. And the second one is the designated port, designated port, okay. You can see the DP, okay. And the third one is a new name, alternate port, alternate port, okay. I think someone is joining now, let's see, okay. the third the third port is the alternate port, okay. And the fourth one is the backup port, okay. So this is new, the backup port, okay. So what is the mean by root port? What is the mean by root port? Okay, the root port means is a port that connects to the root switch or an upstream switch, okay. In the spanning tree topology there should be only one root port for VLAN on the switch, okay. That means if you are configuring VLAN 1, default VLAN 1, VLAN 10, 20, okay. So for entire switch, okay, when you configuring VLAN 10 and 20, okay, for the VLAN 10 there's only one root port, okay. VLAN 20 there's only one root port, there will be no second root port, okay. The second port must be the block, okay. So that's the meaning of this, okay. When the root port, okay, that connects to the root switch, okay. The root switch means the upstream switch, okay. The upstream switch is a non-root bridge, okay. Is and after that the spanning tree topology is only have the one root per VLAN, okay. That means like this, okay. That's called the root port, okay. And the designated port, okay. And the designated port, okay, a network port that receives and forward frames to other switches, okay. So that means always the designated port have the core switch, okay. For an example, core switch, it's getting the it's receiving the all the network traffic. After that it will send the all the traffic to the core router, okay, for the core layer. So the designated ports provide connectivity to downstream devices, that mean the layer 2 devices and switches. There should be only one active designated port on the link, okay. There should be only one designated port, okay. That's what mean by designated port. And the alternate is a new one, okay. It's a new port, but you can see it's same as the port that we are using in the STP, okay. So alternate port mainly is going to be to root, okay, if the current root port fails, okay. So think there's a switch, okay, have a two links. Okay, now like this concept, think this is the root port. Okay, so think this is the designated port. Okay, this is the block port. Okay, and this will be designated again. Okay, so now think this link is failed. Okay, what happened after that? Automatically this link will be change the status as root port and the designated port. Okay, so we will see that actually. Okay, what happened for this, we need to know. Okay, actually, let's see again. I'll get us two switches. Okay, okay, so next I'm going to connect it 0 0. Okay, again okay, okay, first let's see the status of these interfaces, then I'll add the new link. Okay, it's better. So I'm going to start these switches and get the console back. uh, okay, one is in here. Okay, IO2 in here. Okay, so let's see the spanning tree first. Shows spanning tree. Okay, now you can see in my ethernet 00 of my IOU 1. Okay, is root forward. Okay, that mean IO2 is the root bridge. Okay, because they are not mentioning the root. Okay, because you can see the it's change. Okay, it's changed the MAC addresses. Okay, so now see it's this is my root port. Okay, and let's see the IOU2. Okay, in IOU2 have a designated forward. Okay, you can see this is designated forward, which is going to get in the all the traffics and process, and after that it will forward to another networking device. Okay, so that what means in designated forward. So okay, so now this is the main thing. Okay, so next I'm going to okay, add a new link. Okay, I'm going to add a new link 0 0 0 1 and 0 1 here. Okay, now let's see what happened for these interfaces. Okay, first let's see. Okay, again let's see. Now you can see which I show you in my little diagram. Okay, this is a root port, this is a designated port. Okay, now again in IOU2. Okay, okay, so sorry, in IOU1 it's how to be changed. Okay, okay, so let's see again in here. Okay, now it's different. Okay, now 0 my 0 0 is the root bridge because I changed the tabs. Okay, okay, so again I'll show you. Okay, now you can see in my 0 0 of my IOU1. Okay, this is IOU1 is a designated forward which is getting the traffic. Okay, let's see, is a designated port. Okay, is a designated port. Okay, then we can see the what is the status of the this side interface is root forward. Okay, that means it's a root port. Okay, now let's see the Ethernet 0 1 of the IOU1 is a designated forward. So every interface which is have the designated port okay, it's come only with the root bridge. Now this switch is my root bridge. Okay, now let's see the what happened for the 01 is 01 is the block interface. Okay, now only one interface is forwarding the traffic, right? Okay, now this 00 is the port which is going to be send the traffic. So I'm going to shut down this interface now. Okay, let's see what happened after that. First I'm logging to that interface ethernet 0/0. Okay, so I'm going to shut it down. Okay, now the topology will update. Okay, so let's see what happened for this side. Okay, now still the core layer. Okay, still the core layer is same, right? Is the core layer is not changing because it's our designated forward for the two interfaces. Okay, Ethernet 00 and the 01 is designated forward. Okay, but when we check this, okay, when we check this one, check out this one. Okay, I think another one is again logging. Okay, let's wait. Okay, so when we check again the spanning tree, okay, now you can see what happened for the 00. Is the 00 is showing in here? No, right? Because it's administratively shut down. Now my Ethernet 01 by default will come for the route forward. Now it's forwarding traffic. Now the block interface is changed to root port. Okay, so this process is called the alternate port. Okay, the change. Okay, you can see it really. Now is there any port for the block? No, because there's a one port is shut down, because after shutdown there's a no loop happening. Okay, there's a no loop. Okay, there's a no loop in here. Okay, okay, so this is the port status, okay, of that. And next I want to tell you that the backup port. Okay, let's see, let's minimize this one. And next I'm going to talk about this the backup port. Okay, okay, so what does it mean by backup port? Okay, so mainly the backup port is used to provide the link redundancy toward the current route switch. Backup port is a port that is connected to a LAN segment where the same switch has already a better port. Okay, that means the port, okay, exists only when the multiple links connect between the same switches. Okay, same as the backbone fast. Okay, so state is blocked. Okay, so that means sorry, that means I think again someone is joining. Okay, so think again. I'm going to connect few separate interfaces 02 to 02. Okay, 03 to 03. Okay, let's wait. 03. Okay, now there's another two interfaces, right? So let's see what happened for that. Okay, those interfaces. Now I'm going to check the spanning tree, show spanning tree. Okay, now you can see, now you can see clearly. Okay, now you can see clearly. Okay, I'm adding 02 and 03, right? So when I'm adding 02, is come for the designated learning. Okay, and 03 also designated block state now. Okay, after that, okay, when I check again, okay, when I check again, okay, both are designated forward interfaces. Okay, first it will blocked, okay, and second it will learn, okay, and next both will come the designated forward. Okay, now it's waiting for receiving the traffic. But in other hand, okay, but in other switch, okay, let's see what happened to the second switch. Shows spanning tree. Okay, now you can see only the 01 is forwarding the traffic. Okay, okay, so but in the 02 and the 03 will be alternate block, because the state is blocked. The backup port, the backup port, the backup port, the backup port, the state is the block state. Okay, that's the real thing. Okay, you can see it clearly. Okay, these two same as backbone fast. Okay, so that I want to show you that these things. Okay, so these are backup ports. When the ethernet 01 is fail, the someone is going to be root 4. Okay, I'll show you that. Okay, again I'm going to okay, can you hear me? Hello, is my voice clear?
Yes, sir.
Okay,
Yes, sir.
again someone is logging. Yes, okay, okay, so the thing is what I'm going to do is I'm going to logging the interface the ethernet. Okay, 0/1. Okay, 0/1 is root forward, right? Now I'm going to disable that interface, so I'm going to shut it down. Okay, okay, let's wait. Let's wait. I'm going to exit. Okay, and next I'm going to show the spanning tree. Now you can see. Okay, 01 is missing. Now the 02, the next interface. Okay, the next physical interface of the 0/2, because it's our method, because when you get a 01, okay, and 0/2, again next is 0/3. So now the 0/2 is the lowest physical port, right? The lowest physical port, so it will become the root forward now. Okay, you can see. Then the 0/3 is still in the alternate block state. Okay, so this is the what it called the backup ports. Okay, is it clear?
So can we pre-configure the backup ports?
The configurations.
Yes, sir.
Yes, so okay, the pre-configuration means, okay, when I again unshut it down, okay, let's get the configurations. So config t, okay, so interface range ethernet 0/0 to 1. Okay, and I'm going to unblock it. Okay, okay, the entire topology will be changed. Okay, next I'm going to check the spanning tree. Okay, now you can see, now you can see. Okay, now you can see there's a one route forward. Okay, there's a one route forward. Okay, and other three is become the alternate block, right? So these are the backup ports. Okay, when when the first one is something failure or happening, the other one will come in to route forward, okay, and forward the traffic. Okay, if something happened to this interface, okay, the next one will come, change the alternate block state to route forward, okay, and generate the traffic. Okay, that's what happened in the backup ports. These are backup ports, but the state is originally it's block. Okay, the original state is block. Okay, is it clear now?
Yes, sir.
Okay, cool. Okay, so next we have to talk about the negotiation and the other steps, the tuning, STP topology tuning and the enhancement. So it's a lot of theories, okay, which I want to show you and configure. Okay, so let's start with next week. Okay, the RSTP negotiation, the port types, differences, and the tuning and the enhancement. Okay, I'll show you how to tune in the STP and the enhancing the speed and other stuff. Okay, the parameters. Okay, so that is for today. So I think you all clear today lesson. If there's any doubts so regarding this lesson, so you can ask now. If there any Q&A, you can ask. Is there anything? Hello. Hello. Is can you hear me? Can you hear me? Is my voice clear?
Yes, sir.
Yes.
Yes.
Okay.
Yes, sir.
So is there any doubts regarding the lesson? So I already record the video, okay, the regarding this first lesson. So I'm going to upload it to the Google Drive and share with the
Sir,
okay. Yes.
sir, can we change the backup route forwarding port manually?
Yeah, what we are doing is manual. When we shut down the interface, it's manual, but something happen, it's automatically, it will be
Yes,
automatically happen. Yeah,
I think it will be happened automatically, sir.
yeah. The thing is, the automatically means it's manually because I'm changing this things because the interfaces are already in upstate, but some anyway I shut down it manually. The interfaces I shut down. That's why the interfaces are automatically assigned for the route forward. But think something when come to the production network, think some administrator is coming to the switch side, okay, and unplug the one of the cable, okay, so there's a no connection, right? So like that situation, okay, so this the backup port will come in the route forward, okay, if it configured. If not, there's no, okay, so it has to be a physical links, okay.
Okay, clear, sir.
Okay, so is it clear? The others are not talking.
Clear, sir.
Okay, so just for this week, just do this configuration and master the steps what I configured. Okay, so if you have a production switches, okay, you can configure it on the production switches. Okay, if you have any dummy switches, you can configure that. But okay, next week I'll show you how to set up the GNS tree and how to add the images. Okay, so I already have a package, okay, I already have a simple package that we can configure the networking device and other stuff. So I'll show you to configure one of your laptop or computer. I'll configure that remotely, okay, then I'll show you how to configure that. Okay,
Sir, before the lecture, can you share the whole packages
yeah,
in
before the
our?
before the lectures I'll share the all the requirements, the packages and the softwares. Okay,
Okay, thank you very much, sir.
okay. Okay, then see you in next week. Okay, guys. Okay, good night.
Good night,
Good
sir.
night, sir.
Okay.